So this is 17.5, and this will wrap up chapter 17 for us. And so we're going to do the first and the second objective for this one. Now, when you do these are slightly different. You don't graph them on a number line. So here was the best thing to do is to go ahead and rewrite it as an equation, just so we can go ahead and graph it, right? So that becomes y is equal to 3x plus 1. So we're going to go ahead and do a table. So I'm just going to pick when x is 0, y is equal to 1. You can see that 3 times 0 is 0, and 0 plus 1 is 1. Then we're going to go ahead and pick 1. So 3 times 1 is 3, plus 1 is 4. So the two ordered pairs that I'm going to graph in order to do this line, it's going to be 0, 1, and 1, 4. So x is 0, y is 1, that's that one. Then x is 1, 1, 2, 3, 4, and y is 4. Now, this symbol, less than or equal to, tells us that we're going to do a solid line. And I'm going to, of course, I'm doing this by hand, so you have to bear with me. Let me do it a little better than that, though. And so we're just going to have something that looks like this, right? Solid line. Next thing you're going to do is you're going to pick a test point. Now, test point doesn't matter. It can be on this side or it can be on this side, right? Don't pick a test point that's on the actual line. So I'm just going to pick the origin. If you can pick the origin, then just pick it, because it just makes life easier. So I'm going to go ahead and plug in 0 for x, and I'm going to plug in 0 for y. So I'm going to go 0 plus 0 is less than or equal to 1. 0 is less than or equal to 1. That's a true statement. Since that is a true statement, I'm going to shade the region where my test point lies, which is this region right here. So first, graph it. Make sure you get the right line. If it's less than or equal to, it's a solid line. If it would have been less to, it would have been a dashed line. So and hopefully the next example is like that. All right, so let's do this one here. So here we have negative 4 is less than 5x. So what I'm going to do is I'm going to go ahead and just do this. I'm going to go ahead and move the 4 over to this side, and then let's just go ahead and see if we can pick a test point. A graph or equation here. So in order for this inequality or this equation here to equal to 0, what's going to happen is that if I pick 0 for x, so 5 times 0 is 0. 0 is equal to 4 times y, so y can only be 0. Right? And so that's the first point that we have. If I pick another point, if I say that x is equal to 1, right? And so I'm going to go ahead and do 5 times 1, which is 5, plus 4y. Subtract the 5. Subtract the 5. And then I get y is equal to negative 5/4. So I don't really want, I can use this, let me write this a little better. So it's 5/4. So if I were to graph this, my ordered pair would be 1, negative 5/4. So if I go to x is 1, now negative 5/4 is 1.2, negative 1.2. So I'm just going to go ahead and put it right there, right? Because this will be negative 1 and this will be negative 2. Now, it is a less than, so it's going to be a dashed line. So I'm just going to go ahead and do a dashed line. And that's my dashed line. Next thing I'm going to do is I'm going to choose a test point. Now, remember I told you before, if it goes to the origin, then you got to pick another one. So I'm just going to choose 1, 1, right? That's my test point. So negative 4 times 1 is less than 5 times 1. So negative 4 is less than 5. That is a true statement. So I am going to shade the region that has my test point. Okay. All right, let's go to the next one. So here we have 4x. So I'm going to do 4x is equal to negative 12. And I can subtract that, and x is equal to negative 3. So when x is equal to negative 3, what's going to happen is that I go over to negative 3. So this is negative 1, right? Negative 1. This is negative 3. So what happens is that x is always going to be negative 3. Now, if I think about my inequality and I divide both sides, it's telling me that x is going to be greater than or equal to negative 3. So then that means that where are the values that are greater than or equal to negative 3, they're going to be to the right. And that's how you do this particular example. So the next one, in two variables. So here, what happens is you have an and situation. So I'm going to treat these both as just equations in order for me to just graph them, right? So here, when x is 0, I get 1 for y. When x is 2, so 1/2 times 2 is 1. 1 plus 1 is 2. So those are my 2 points. Now I'm going to graph this one in red. So 0, 1 goes right there, and then 2, 2 goes right there. And it's a greater than, so it's going to be a dashed line. Right? Let's do the other one. When x is 0, then that means that y is equal to 1. So I'm going to graph this one in black. And then, of course, if I make x 1, I'm going to have 1 plus y is equal to 1. So y is equal to 0, and I get y is equal to 0. So it's going to be 1, 0, which will be right there. Now, it is a less than, so it's going to be a dashed line. All right? And so let's look at both of these here real quick. Here, the first one, if I pick at this point, I'm going to pick 0, 0 for both of them. So y is, it's going to be 0. So 0 is greater than 1/2 times 0 plus 1. 0 is greater than 1. That is false. So since it's false, and I'm looking at the red line, the 0, 0 is going to be above the line. And so it's going to go right there. Now, if I do it now for the next one, 0 plus 0 is less than 1. 0 is less than 1. Then I am going to shade where the region includes 0, 0, which will be below the black line. Let me make sure I can, right here. Now, the issue with this is the following. We're looking for and. That means that they have to have something in common. And so the region that they have in common is below the second equation, but above the first one. And so this is actually your answer. That is the part of the that's the part that's going to answer the question, because it has to have both of them. They have to have it in common. All right, let's look at this one. So here, if I solve this, y is less than or equal to 2. And then here, right, if I were to solve it, it says y is less than or equal to x. Well, that's the same as saying y is equal to x, right? If we're going to go ahead and graph it. So I'm going to graph the first one. Y is less than or equal to 2. If I graph the just like an equation, then it would be right here where y is equal to 2. Now this one, it says that y is equal to x. I'm going to graph that one in black. So this one's going to go right through the origin. Right? And so now, for this one, let me pick a test point. This one's going to be in red. So 3 times 0 is less than or equal to 6. 0 is equal to 6. So that's a true statement. So I am going to shade everything that's below. Now for this one here, if I pick, this one actually goes to the origin, so I can't pick one. I can pick that. So I'm going to pick -1, the ordered pair -1, 1, right? Which is that one right there. So -1 minus 1 is less than or equal to 0. -1 is less than or equal to 0. That is a true statement. And so since it's a true statement, I am going to graph everything that's above the second equation. Now, since it's an OR, is everything that you shade. Everything that's shaded is part of the solution, as opposed to the first one, which is the AND. So here, it says x is less than or equal to 0. So since x is at, where is x 0 is actually going to be here, right? It's going to be this line right here. That's when x is equal to 0. Now y is equal to 0 on when you're on the x-axis. So the first one is going to be in red. So it says that x is less than or equal to 0. Well, where are the values that x is less than or equal to 0 would be everything to the left. Whereas y greater than 0 is going to be everything to above, sorry. So then your solution for this one, since it's an AND, they have to have it in common. So it's going to be just this area right here. All right. And that is the end of 17.5. Thank you.